All right, folks, here I am. This is my first look at the 2024 AP Stats FRQs. So I'm going to read through this and explain to you what I would do. So, large exercise center, several thousand members from age 18 to 55, several thousand members age 56 and older, considering offering online fitness, investigating whether members' opinions of taking online fitness classes differ by age. The manager selected a random sample in the lower, and then another random sample, two sample. Each sampled member was asked whether they would be interested in taking online fitness. The manager found 51 of the 170, so P hat, and 79 of the 230, another P hat. So it sounds like a two sample Z test for proportions. All right. And you would want to define your parameters, which is the true proportion of those 18 to 55 who would would be interested in taking online fitness classes. And then P2 is the true proportion of people 56 years and older who would be interested in taking online fitness classes. Again, your null is that P1 equals P2. Your alternative, does it talk about direction at significance or conveying evidence of a difference of proportion? Okay, who would be interested? So my alternative is P1 does not equal P2. So that makes it a two-tailed test. And then checking your conditions, you want to take the number of successes, which is right here, 51, and the number of failures is just 170 minus 51 is 119. The number of successes and the number of failures is 230 minus 79 are all greater than or equal to 10. And therefore, the sampling distributions are all approximately normal. I think you can also use an n greater than or equal to 5 when it's a two sample Z test for proportions as well. And then independence, it says that there are several thousand members. And so we're not exceeding 10% because we're sampling without replacement from a finite population. And so you want to check that 10% condition. And then they were randomly selected, simple random sample. So we have conditions met. You name the test or show the formula. The formula is a mess, but you can use it. You have to use P hat combined here. P hat combined because we're under the assumption that P1 equals P2. And so if you're putting stuff into the calculator, you can write down like the successes and trials for each. And then you'd want to list your P hat combined, list the calculator degrees of freedom. Otherwise, you take the smaller of the n minus ones, which would be 170 minus 1 or 160 degrees of freedom. If you're doing it by, no, you don't need degrees of freedom, Mr. Crayons. It's a Z test. All right. So anyhow, you calculate your Z score using the square root of P hat Q hat times 1 over N1 plus 1 over N2. So 1 over 170 plus 1 over 230. But they get both that square root of P hat Q hat. And you get your Z score. It seems like those are pretty different proportions. And so you'd probably get a small p-value, reject the null, and go ahead from there. There's no part B. Sweet. Elementary school wants to sell bottles printed with the school district's logo as a fundraiser. The students in elementary school were asked to sell bottles in 3 different sizes. The relative frequencies for the elementary school were 0.5, 0.3, 0.2. So 0.5, 0.3, 0.2, and you want to shade in that bar graph. A local middle school also decided to sell bottles using the same 3 sizes. The middle school sold 3 times the number of bottles that the other one did, but the proportions were equal for all 3 sizes. So you're going to make the identical stacked bar graph. Okay. Your segmented bar graph should shade 0.5, 0.5 for the small, and then it should go over to 0.8, and 0.8 for the medium would be white, and then really colored in for the large would be 0.2 on the right there, the last 0.2. Is concluded that the elementary school students sold more bottles than the middle school students did. Is the elementary school administrator's conclusion correct? Oh, wait, I misread this. The relative frequencies of the number of bottles sold for each size by students at each school. Oh, no. The proportion of bottles sold was equal for all three sizes. Oh, so at the middle school, it's 1/3, 1/3, 1/3. So you want to go 0.33 and 0.67. So here, it's 3 times the number of bottles. So if this is n times 0.5, okay, this is 1/3 of 3n, okay, because the proportion is 1/3 and it's 3n. And so at the middle school, 1/3 of 3n is n, and 0.5 times n is 0.5n. And so I would argue that this guy is wrong, okay? And then, and I would show that 0.5n is less than 1/3 of 3n, or 1n, all right? And then high schools are also selling bottles. A mosaic plot for the number of bottles sold at 2 different high schools is shown here. Which of the 2 high schools sold a greater proportion of large bottles? So right here, high school A is 70%, high school B is 60%. Hopefully you can read a mosaic plot. That's pretty straightforward. Which of the 2 high schools sold a greater number of large bottles? And that's based on the area here, and high school B has a greater area, and so high school B. Car maker produces 4 different models, A, B, C, D. A group of researchers investigating which model has the longest distance traveled per gallon. Higher gas mileage is considered better than lower gas mileage. Thank you for reminding us of that. We'll conduct a study in which several owners of each model of car are asked to estimate their mileage. Observational study or experiment. They did not randomly assign them to treatments, and so if they randomly said, you need to buy Model A, you get Model B, you get Model C, you get Model D, that'd be an experiment. So it's lacking random assignment. Model D has an autopilot feature, in which case the car controls its own motion with human supervision. James owns a Model D car. James will drive his car 70 different days to and from work using the same route at the same time each day. James will use a completely randomized design to conduct his investigation. Describe an appropriate method James could use to randomly assign the true treatments, driving using the autopilot and driving without, using the autopilot feature, to 35 days each. Okay. You want to be careful. You don't want to say flip a coin, because once one hits 35, then the last however many days would all be the other treatment. And that's not random. Okay. You are systematically favoring the last handful of treatments to all have the same, or the last trials to all be the same treatment, and then you're not random. So I would want to number the days 1 to 70, put it in a hat, nice P hat, shuffle it up, pick out 35 of them without replacement, and those 35 days you would do the auto pilot feature, and then the remaining 35 days in the hat, those 35 days would get the driving without the autopilot feature. Okay. And then you would record the mileage for each of those. After the investigation, James verified the conditions for inference were met, conducted a hypothesis test. He discovered the mean mileage when using the autopilot feature was significantly higher than the mean mileage when not using it. He's a member of the Model D Club with thousands of members who all drive. He'll give a presentation much later in the year, and would like to state that the results of hypothesis tests. Another member who is a statistician tells James his findings do not apply to all Model D cars in the club. What change would James need to make to his original study to generalize? Good question, right? So we can only conclude it, right? It's randomly for the cars that were volunteering to participate in the study, and it's just James's car is the only one we can conclude it from. So you would need to take a random selection of Model D cars and have them compare 2 different things, and you did a match pairs design or something like that. But you need to randomly select Model D cars in order to generalize to all Model D cars. Good. All right, number 4, online game. Players move in a virtual world collecting geodes, a type of hollow rock. When broken open, these geodes contain crystals of different forms that are used in the game. A red crystal is most useful. The color of the crystal in each geode is independent, and the probability that it contains a red crystal is 0.08. Oh, man, this reminds me of the speed run. The speed run, but and that whole mess with the goblins or whatever they were. Piglins? whatever. Sarah, a player will collect open geodes until a red crystal is found. That sounds geometric to me. Calculate the mean of the distribution. Well, that's on your formula sheet, so that's pretty easy. Write down the formula, plug in the numbers, and you're good. Calculate standard deviation, also on your formula sheet. Plug in the numbers, you should be good. Where your P is 0.08 and your 1 minus P is 0.92. Okay. Another player decides to play the game, will stop opening after finding a red crystal or when 4 geodes have been opened. Whichever comes first, let Y equal the number of geodes Conrad will open. The table shows partially completed distribution of the random variable Y. So this is 0.08. This is 0.08 times 0.92. And then this is 0.08 times 0.92 times another 0.92. Okay. And then this needs to be the rest to add up to 1 because whether or not it gets the red geode, he's going to stop. Okay. And so this one's easy to calculate. Just multiply that times 0.92. And then this is 1 minus those 3. Okay. P of Y equals 3, P of Y equals 4. Easy. Consider the table and your results from part B. Calculate the mean of the distribution. And if you just do n times p, n times p, n times p, n times p, or x, y times p, I guess, and add those up. That's going to be your expected value. And then interpret the mean of the distribution of geodes Conrad will open. So in the long run, if he did this game many, many, many times, in the long run, he would average whatever number you got here, number of geodes that he would open per game. Okay. All right. Baseball cards are trading cards. I used to collect those as a kid that feature data on a player's performance in baseball games. Michelle is at a National Baseball Card Collectors Convention, 20,000 attendees. Some collectors have regular, which are obtained easily, and rare, which are harder to obtain. Michelle believes that there is a relationship between the number of months a collector has been collecting baseball cards and whether the majority of the cards are regular or rare. She obtains information from a sample of 500 baseball card collectors at the convention and records how many. So this is a single sample, and we're categorizing 2 categorical variables. So I don't know what the questions are going to ask, but this is a chi-square test for independence. Okay. If a collector in a sample selected at random, what's the probability that the collector has been collecting baseball cards for 11 or more months? So all of these. And has a majority of regular. So you would add up these guys out of 500 because it's an and. So it's this group plus this group plus this group. That's 11 or more months and has a majority of regular, and it's not conditional. So it's right there. Given that a randomly selected collector from this sample has been collecting cards for fewer than 6 months, so given that they're in this column, so it's going to be out of 91, what's the probability that the collector has a majority of regular? 80 out of 91, okay? And then Michelle believes there's a relationship between number of months and which type of card. Name the hypothesis test. I already did that. Chi-square test for independence. State the null and alternative. Null is that the majority of baseball cards being regular or rare is independent of the number of months that they've been collecting baseball cards. And the alternative is that it's associated. Okay. You could say not associated or independent in the null. You could say associated or dependent, which I hate that word in the alternative. After completing a hypothesis test, she got a p-value. Assuming the conditions for inference met, what conclusion would she make about her belief? I would reject the null and say that there's sufficient evidence to suggest that there's an association. All right, finally, number 6, a company sells a certain type of whistle. The price of the whistle varies from store to store. Julio, a statistician at the company, wants to estimate the mean price in dollars of this type of whistle at all the stores that sell the whistle. Identify the appropriate inference procedure. Estimate the mean price in dollars of this type of whistle. So it sounds like a one sample t interval, right? You want to make a confidence interval. If you're estimating the mean, when you're estimating, you create a confidence interval and you're that percent confident that you capture the true amount. we don't know the true standard deviation, doesn't mention it. So I would talk about a one sample t interval. The parameter is the true mean price of the whistle at all stores that sell the whistle. Okay. So he called 20 managers at randomly selected stores that sell the whistle, recorded the price of the whistle at each store. That's the dot plot that we see. Summary statistics, we see that. He wants to examine some characteristics, describe the shape of the distribution of whistle prices, justify the response using appropriate values. Okay, so it looks like the majority of the data is down here, and then there's a few to the right. I don't necessarily know if they're outliers, but you can do Q3 minus Q1, and you're looking at like 0.9 times 1.5 is going to be 1.35. And if you add that, that's not outliers, and going below that, definitely not outliers. And so there doesn't seem to be a lot of outliers. The mean is greater than the median, which is evidence that it's slightly skewed right, but there's no outliers. And so you can talk about shape, center, spread, outliers, put it in context. And then here, I just did that. Are there any outliers? I don't think so at a quick cursory glance. And then here, it can be difficult to determine whether it's skewed. And so Pearson's coefficient of skewness is using this formula 3 times x bar minus the median. No, x bar is the sample mean, m is the sample median, and s is the sample standard deviation. It's you're just plugging in x bar minus the median. So I would do 5.12 minus 4.885 times 3 divided by 0.743, and you get some cool number. All right. The following graph shows the conclusion that can be made about the shape of the distribution based on Pearson. So here we're looking at 20, and depending on where you are, if you get something below negative 0.77-ish, okay, then I would say it's strongly skewed. And we're actually going to get something to the right because 3 times point, what do we get a difference of? 0.3 is like 0.9 divided by 0.7. We're getting 1 point something. And so we would say that it is strongly skewed to the right. Okay. So I'd mark it over here. You should conclude that it's strongly skewed right. Why? Because it's in that region off to the right. Julio's inference procedure, sample size greater than or equal to 30. If it's not, the distribution is not strongly skewed and does not have outliers. Is the normality condition satisfied? Well, it needs to be not. If we are less than 30, the sample data we just said right here is strongly skewed to the right, and therefore, no, we have not met the normality condition for this. And now we're done. So I hope you did well. We'll check out the AP Stats Medics rubrics for these in class. Good luck and farewell.